We're going to start by reviewing our scientific notation. You guys remember this, right? Who remembers scientific notation? Yay, okay. It's a way, shorthand way to write very big or very small numbers. That's why we have it, right? Because it's hard to write numbers with like tons of zeros. So here's how it works. You have something times 10 to a power. Now this thing, we call it a coefficient. This number has to be between 1 and 10. Now it can be 1, but it can't be 10. That's what this notation means. This number, C, is bigger than or equal to 1, but less than 10. And n is an integer, which means what? What's an integer? A whole number. Give me more.
Anything that's not a decimal.
Positive and negative.
Anything that's not a decimal. A positive or negative number. Is zero an integer?
No.
Yes.
Oh, never mind.
So it's like -3, -2, -1, 0. Right? These are integers. This goes forever and this goes forever. But a half is not an integer. Negative 0.75 not an integer. So that's what this is. So the idea is, well, let's do it this way. Is this a number in scientific notation?
Yes.
Is this number between 1 and 10?
Never mind.
Yeah.
And is this an integer?
Yeah.
Is this number
Yes.
ooh, that's a tricky one. Yeah, I mean, this the actual value of this number. Let me just take that positive. That's a little tricky. How about this one?
Yeah.
Yes. Yes. Right? This is an integer. How about this one? Why not? It's
So it
not.
can't be 10.
Can't be 10. So 57 times 10 to the minus half. How about that? Two reasons, right? This is not it's not a number between 1 and 10, and this is not an integer. How about 5.7 times 10 to the 6?
Yes.
Okay. Those are scientific notation numbers. So if you start with a number in a standard form number, how do you turn it into scientific notation? I'm going to make it a product, right? A number times a power of 10. So you say, well, what's the number? So you look at where they start at 2 point whatever, right? Because I want it to be a number between 1 and 10. So I would put a decimal here. Well, how many zeros are after that? 1, 2, 3, 4, 5, 6. 10 to the 6. Now, if you have a negative exponent, you guys did negative exponents here, right? We have scientific notation. You're saying, well, that means move it to the left, right? So I still have to make it a 5 because it has to be a number between 1 and 10. And how many did I move it? 1, 2, 3. Now, how do you know this is a positive 6 and this is a negative 3? Like, how do you know that? Left and right? They told, just remember that. Right? No, they didn't tell you to remember that.
They told you that.
They say why? Why does 6 mean make it going to the right and negative means going to the left?
Because
The exponent is positive.
Okay, but why does that mean go right or left? It just does. Let's expand this. That's 2 times, I've got 6 factors of 10, right? 1, 2, 3. This is a multiplication expression, and I can do that, right? When you multiply a number by 10, is it going to get bigger or smaller? Bigger. Bigger. And it gets bigger in such a way that it's like moving your decimal to the right, isn't it? 2 times 10 is 20. 20 times 10 is 200. Every time you multiply by 10, this number gets another 0 added. And that's why that comes out to 200. Now what about this? Now we know what a negative exponent means. Is this negative 3 happy? What's another way I can write this? So that this is a happy number? 1 over. Remember? It's in the numerator not happy, put it in the denominator happy. Everybody's watching? Because not everybody looks like they're watching. We agree that this and this are now the same thing. Okay. Let's think about what that is. That's 5 times, I'm going to rewrite it like this. What do you think about that? Are these equivalent? Think about that. 1 to the 3rd power is what? 1. 10 to the 3rd power. It is. So that's 5 times 1 over 10 times 1 over 10 times 1 over 10. Isn't it? Yeah. So if I'm dividing, I'm multiplying by 1/10. My number going to get bigger or smaller? Think about that, right? Because 5 times 1/10 And that's why we're moving left. A negative exponent means you're dividing by 10, and whenever you divide by 10, you move to the left. So now we know why, rather than just memorizing it. Okay?
Also, if it's negative, it's gonna be smaller.
Right, but now we know why it's getting smaller. This is dividing, this is multiplying. Multiplying makes bigger, dividing makes smaller. Okay, so let's just practice. I want this number standard form to scientific notation. I say it's this. How come? Right? You move, you say, these are my numbers, right? And I'm always going to put the decimal there because I want it to be a number between 1 and 10. How many times now to get back here? Well, I have to go 1, 2, 3, 4, 5, 6, 7. I have to multiply by 10 7 times to get back there. So I'm moving the decimal 7 places to multiply. Oh yeah, from here. Okay, this one, 5.74, 574.0000. Right? What is that in scientific notation? Yeah, Ryan, how do I do that? Minus. Now, why is it minus? I'm going to take this number and make it smaller. So I'm here, right? 1, 2, 3, 4, 5. And the idea is do this multiplication when you get back here. So I need 5.74 to get smaller to get back here. So that's negative exponents. So it's like I'm moving this decimal to the right. But then I have to kind of account for moving it back. That's how we do it. Okay? Now if I start with scientific notation, how do I get back? Well, you're multiplying by 10. 1, 2, 3, 4. I've run out of room. I'm going to be adding zeros. That's where this comes from. And then if I have one that looks like this, I'm going to do what? I'm dividing by 10. What happens to this decimal? My number gets smaller. How many times? 4 times. Well, there's 1 time, 2 times, 3 times, 4 times. So I'm putting in zeros to kind of hold that place for when I move over. So do we remember this much?
Yeah.
Raise your hand, I remember this much. So, I do. I remember it. What? Okay. Ordering numbers. Now we did a little bit of this last year too, I'm pretty sure. The easy way to do this is put every number in scientific notation. Order based on exponents. Bigger exponents have bigger numbers, right? Because you're multiplying by 10 that many more times. If the exponents are the same, you look at that coefficient part, that number between 1 and 10. So if I wanted to order these, you write them in scientific notation. 1.034 times 10 to the what? Oh, start here, right? 1, 2, 3, 4, 5, 6, 7, 8. Does this expand back to that? I always check. Make sure that's a positive exponent. Already in scientific notation. 8.076 times 10 to the what? Start at the 8, right? 1, 2, 3, 4, 5, 6, 7. Least to greatest. So what's my smallest number here?
The third one.
This one, because that's the smallest. It's only 10 to the 7. This is 10 to the 8. So this one's going to be smaller. Now when I reorder it, you can start by just doing it the same way. Now I look at these two. The exponents are the same. So who comes next? Who's smaller? You just look at these numbers now. 1.034 or 7.8? Okay, so that comes next. And so I guess this is my biggest number. Now always put them back where you started from. So 8.07, that's really 80,000, 760,000. That's this one, that's billion, I don't know what's going on here. 103,408,000. And this one was in scientific notation. So this would be your answer. And I think you guys did this last year as well.
Yeah.
Yep. Take a review. Ms. Mullen, yay, Ms. Mullen. Okay. This part I think is really great for all of them. Too bad you're coming now. You had great teachers up till now. Okay. So here we go. Multiplying and dividing numbers in scientific notation. So do you see where we are here? We're kind of in the middle-ish page 3. I want you to write this. Do not expand the numbers. You're writing this, see where in the middle of the page it says multiplying and dividing, and it says use law of exponents just like up here? Do not expand the numbers. Meaning, don't take a number in scientific notation and make it, that 10,765,000. Don't make it that big number then. Because the reason we're doing this in scientific notation is to make the multiplication easier. It's hard to multiply big numbers. So don't expand them. Everybody wrote that down? Now I want you to circle it. And then I want to see like a bunch of exclamation points and stars. This is important, right? Okay, so we're going to actually use the laws of exponents to help us. The only tricky bit with this is when you're done, just make sure your number is in scientific notation, and I'll show you what I mean. Does everybody see this example? Towards the bottom of the page, you all see where it is? Okay, so 8.5 times 10 squared times, right? Do you see anything here? There's no operator. If there's no operator, what is this? It's a times. For now, I'm just putting it in. Now, you don't have to do that, but I'm just putting it in here. 1.7 times 10 to the 6th. Is everything here being multiplied? Who remembers the name of the property that says if you're multiplying, you can multiply in any order?
Multiplicative property, equality.
No.
That's
So I
commutative
commutative property multiplication. Can I change the order that I multiply these things? They're all multiplied, right? So I'm going to change the order so that the coefficient part, the number parts come first, and then the powers of 10 come next. Okay? What's 8.5 times 1.7? I don't know. That's you may use the calculator for that. 8.5 times 1.7. 14.45
14.45.
times, now, 10 squared times 10 to the 6th. These are powers with the same base. How many factors of 10 do I have? 2 factors here, 6 factors here. Look at that. Now, is it scientific notation? No. It kind of looks like it, but what's the problem?
Oh, the top one.
Not a number between 1 and 10. Well, yeah, what do? I divide by 10? Don't I? Because I want it to be a number, so I'm going to move that. Now, let's think about what happens to my power of 10. This one said from 14.45, go 8. Now, I went to the left. So how many times do I have to move over to get the same number? Why 9 and not 7? Ooh.
It's 9 because you already, if you lose 7, you already have a big number, so that's not in 10. So if you lose 7, it's going to be 1 more.
Well, and I like what Ryan said. He said, once you divide by 10, I'm dividing by 10. So what happens here? I'm confusing myself, so I'm going to leave it. I like just thinking about it. This number, if you expand it, if you start here, you get 8 zeros. If I move it back 1, I need to multiply by another 10.
Okay.
All right, now let's try this one. What's the rule? I'm squaring a number in scientific notation. Well, when you multiply two things and you raise it to a power, what happens? The 2 goes to that, and the 2 goes to that. You get 1.5 squared times 10 to the what? 10 to the what?
Negative, or 10 to the negative.
Power to a power you multiply.
But
Yes?
for the last one, if you moved over the decimal, you would make it would be 10 to the power 9, right?
Yes. Because think about this. When you expand these two things, you should get the same number. Will I? From here going 8 times, and from here going 9 times, I'm going to get the same number. What's 1.5 squared? Let's find out. 1.5 squared? Not 3. 2.25 times 10 to the minus 6. Last thing you should say, is this number in scientific notation? Yes. This is a number between 1 and 10. Done. Yes. So think about that. So what do I mean by don't expand the number? I don't want you to figure out what that is, because what is that? That's 0.0015. And then you're going to square that? Don't. Do this. You're less likely to make a mistake. Okay. Dividing. All right, let's look at dividing. Oh, the bus. Now again, something times something over something times something. Please stop talking. So think about what we did before, when we had like, AB over, E squared, B squared. Remember how we dealt with this and then we dealt with that?
Yeah.
We're gonna do the same thing. Let's deal with this. What's 5.891 divided by 4.3? You got it already? What's 5.89 divided by, okay, what? 1.37? You get the same thing?
Yeah.
Times? I've got the same power, right? What do you do if you have the same power and you're dividing? Minus 3 minus negative 7.
4.
Minus 3, what? That's a 4. Is that in scientific notation?
Yeah.
Oh, it is. I'm done. Woo! Done. Let's try this one. Now you divide 2.19 divided by 3.2. I did this one before. What did I get? Something right.
0.684.
375.
Yeah.
And you move it times. Wait. Now what happens with my power of 10?
11.
9 minus negative 2. Is this scientific notation?
No.
No. What's wrong with it?
Okay.
All right, Sam, tell me what I have to do here. Okay, now let's think about what happens to our power of 10 now. Whoops. Now this one, before I was going 11 moves, right? I already moved it once. How many more times do I move it?
10.
Is that scientific notation? Done. That's it. So multiplying and dividing, if you keep them in scientific notation, use your laws of exponents. It's easy. All right? I've got some for you. You try while I'm going to give out the homework paper while you're trying. Oh, you have the homework paper. Come on. What's the homework?
Oh, the back of that page.
Work these you tries. Work these you tries. I'm going to put the answers up. When you get down here, in fact, start with these. You know how to do this, right? Start with those. Do not expand the numbers. Do not. All right, go give it a try. Work them. It's too easy. I'm sorry. Do you want something harder?
No, I'd rather.
Okay, I can.
I'm good.
All right.